of zeros and graphical or geometrical interpretation of zeros. Now in part 2, moving towards how to find zeros and the relationship between coefficients of polynomials and zeros of polynomials, right? So let's first talk about how to find zeros of linear polynomial. Linear polynomial. Suppose I am having a linear polynomial p of x equals to 2x plus 3, right? Now to find zeros of this 2x plus 3, I have told you earlier in part 1 as well that we can decide the number of zeros from the type of polynomial we have. If we are having linear polynomial, then it will have or it has only one zero. If we are having quadratic polynomial, then it has two zeros, and if we are having cubic polynomial, then it has three zeros, right? So we can make out number of zeros by geometrical interpretation and by the type of polynomial. Now to find zeros of 2x plus 3, we should take p of x equals to 0, which is 2x plus 3 equals to 0. And to find the zero, that is the value of x, 2x equals to minus 3, so x will be minus 3 by 2. This is the zero of our linear polynomial 2x plus 3. Simple, right? Now, next, quadratic polynomial. When we have quadratic polynomial, and you know the common format or general form of quadratic polynomial, which is p of x equals to ax square plus bx plus c. And it can be solved, or the zeros can be found in two ways. The first one is the polynomial is a perfect square. Perfect square. So you can sum up or summarize, or you can write it in the form of a plus b whole square or a minus b whole square, then you can solve it out. We will see an example related to this further. Now, if it is not a perfect square, then we can solve it by splitting the last term. Split the last term, right? Where you have to multiply a and c, and you have to split that AC to get b. Got it? We will see this type of example and this type of example as well. So you will get the ideas of both methods, right? First of all, we have seen linear polynomial, how to find zero of linear polynomial. Just take p of x equals to 0, then make x a hero. You will get the value of x, which will be your 0. Moving towards quadratic, there are two different ways to find zeros. First one is perfect square, second one is splitting the last term. Now we will try to solve the examples on the basis of these methods. But before that, let me tell you the relationship between zeros of quadratic polynomial and coefficients of quadratic polynomial. Right? We know in this case our coefficients are a, b and c, and we know that we will get two zeros for quadratic polynomial. We get one zero for linear polynomial, and we will get two different or two same zeros for quadratic polynomial. Suppose they are alpha and beta. Now the relationship between these zeros and those coefficients is first relation, which is the sum alpha plus beta equals to minus b by a. B is the coefficient of x, a is the coefficient of x square, and alpha into beta equals to c by a, where c is the constant term and a is the coefficient of x square. You can see that the first relation shows the addition of zeros and the second one is the multiplication of zeros, right? First one equals to minus b by a, second one equals to c by a. Okay, now we will try to find the zeros and then we will check the relationship between zeros and coefficients, which is in the form of exercise 2.2, right? We will try to solve a couple of examples from that exercise. First example is x square minus 2x minus 8. First one, x square minus 2x minus 8. Here we can see that this is not a perfect square. Why? Because its last term is not a perfect square or not a plus either. It should be positive, it should be a perfect square, right? So we will have to apply that second method, which is split the last term or split the AC. Here a equals to 1, b equals to minus 2, c equals to minus 8. Got it? Now AC will be minus 8 and we have to split that minus 8 in such a way that in such numbers that addition or subtraction of those numbers will give us minus 2, will give us b. So we can make out, we have to split minus 8, it will be 4 2s are. Now the question is, whom we will put positive or whom we will put negative. So if you are splitting a negative number, then you will have to keep this in mind that both the numbers will be having different signs. If you are splitting positive number, then both the numbers will be having same signs, right? Here in this case we are splitting negative number, that's why both the numbers will be having different signs. Now the question is to whom we should put negative and to whom we should put positive. Then you will have to focus on B, what you want to get. If you want the minus number, then your bigger number should be minus. And if you want positive number, then your bigger number should be positive, right? So minus 4 and plus 2. Now what should one do? One should divide these parts directly by a, which is minus 4 by 1, 2 by 1, and you will get the factors directly. You can write it in this way: x minus 4 into x plus 2 equals to 0. We are taking p of x equals to 0 to find the zeros, right? So if the multiplication of two different numbers are 0, then mathematics says that one of them must be a 0. So we can conclude like this: x minus 4 equals to 0 and x plus 2 equals to 0. So if x minus 4 equals to 0, then x equals to 4. And if x plus 2 equals to 0, then x equals to minus 2. So we got our two zeros. First one is alpha equals to 4 and second one is beta equals to minus 2. Got it? Now what will we do? We will check whether that relation what we have just seen, which is alpha plus beta equals to minus b by a and alpha into beta equals to c by a, is right or not, right? So first relationship, alpha plus beta, sum of the zeros, 4 minus 2, 4 minus 2 is 2, and minus b by a, minus b is minus 2, so minus of minus 2 divided by a is 1, minus minus plus, plus 2, c, you can see both the answers are same, so we can say that alpha plus beta equals to minus b by a, right? First relationship is true. Now moving towards the second relationship, which is alpha into beta equals to c by a. First one is alpha into beta. Alpha equals to 4 beta equals to -2, 4 to the -8, and c by a. We know that c is -8 here, and a is 1, so -8 by 1 will be -8. Here as well you can see both the answers are same, so you can write alpha into beta equals to c by a. You can see that both the relationships are true for this polynomial, right? Alpha plus beta equals to -p by a, and alpha into beta equals to c by a. So in this example, friends, first of all we have solved, or we have found the zeros of given quadratic polynomial by using the method of splitting the term, splitting the last term. And then after finding the zeros, we have checked whether the relationships between zeros and coefficients are true or not. Right? Now we will solve another example which is there in your textbook in exercise 2.2, which is in the form of perfect square. Number 2, 4s square minus 4s plus 1. First of all, how one can check whether the given equation is perfect square or not, right? So the first term should be a perfect square. Square root of this is 2s. Last term should be a perfect square. Square root of this is 1. And your midterm should be the multiplication of 2 into square root of first term into square root of last term, which is 2 to the 4s, right? Sign doesn't matter. Sign of midterm doesn't matter. Both the terms, the first term and the last term, should be positive only. Then you can consider them as a perfect square, right? So you must have seen this formula, which is a minus b whole square equals to a square minus 2ab plus b square. So you can write in reverse as well. If you are having a square minus 2ab plus b square, then you can write a minus b whole square. And we will be doing this only in this case. We can write p of x equals to square root of first term, which is 2s, minus sine of midterm. See, sine of midterm. 2s minus square root of last term, which is 1 whole square. Now, what we will do? P of s, because the variable is s. We will take p of s equals to 0, which is 2s minus 1 whole square equals to 0. And if the square of any number is 0, then that number must be a 0. So you can write 2s minus 1 equals to 0, 2s minus 1 equals to 0 because square is there. So s will be 1/2 and s will be 1/2. This is our alpha and this is our beta. Here you can see that both the zeros are same. So what we can conclude from this? We can conclude that if the given polynomial is a perfect square, then the zeros of that polynomial will be same only. Right? Now we will check the relationship between coefficients and zeros of the polynomial. First relation, we know that alpha plus beta. Alpha plus beta is 1/2 plus 1/2, and we all know that 1/2 plus 1/2 is 1. Then minus b by a. What is b? B is -4. So minus of -4 divided by a. What is a? A is 4 as well. So minus minus plus 4 cancel out. 1 c. B got the same answer. So we can conclude that alpha plus beta equals to minus b by a is true. Now moving towards the another relationship, which is alpha into beta equals to c by a. First of all, alpha into beta, which is 1/2 into 1/2, 1 by 4, and c by a. What is c? C, it's 1, and what is a? It's 4. So 1 by 4. You can see that both the answers are same, so I can write alpha into beta equals to c by a is also right. Both the relationship are true. What we have understood from this lecture, first of all, we tried to find the solution of the zeros of linear polynomial, then of the quadratic polynomial. Then we have seen the relationship between coefficients and zeros. Then we have done two different examples on the basis of relationship between alpha, beta and ABC, and how to find the zeros by using both the methods. The first one, which was by splitting the last term, and the second one, which was a perfect square method. Right? Now what you will have to do, solve another examples related to this concept. Try to solve from textbook, from R.D. Sharma, whatever reference you are using from all-in-one, right? And if you are finding something tougher, something difficult, then let me know in the comment section, right? And share this with your friends so they can learn at home, right? We will be seeing relationship between coefficients and zeros for the cubic equation or cubic polynomial in the next part. Thank you.